Now that we've had a look at some of the theory, let's go down and try doing some examples to illustrate the process of how we go about solving trig equations. Now down here I've got 5 unique examples of increasing difficulty as we move along. In the first example we have sine x equals the square root of 2 all over 2. And what our objective is to find the values of x that will make the left hand side of the equation equal the right hand side of the equation here. Now we could simply just look up our exact values because we know the sine x, so the value of x would satisfy this particular equation here. One of the solutions is going to be 45 degrees. However, what we're practicing in this particular lesson here is how we go about the process of solving trig equations when we don't know the values. So the first thing I'm going to do to go about solving the values of x is I'm simply going to rearrange the equation in terms of x. To carry this process out, all we need to do is take the inverse sine of both sides of the equation. This will equal x equals the inverse sine of the square root of 2 all over 2. Now the next step involves a bit of visual understanding. So what I recommend doing is drawing a little unit circle like so. You don't have to annotate all the details on it, but just a simple unit circle is all you're going to need. And then we're going to write the mnemonic, so all stations to central. Now, here's where we need to be careful. What we're going to do is we're going to try and identify where sine is positive. Reason for that is because if we're looking at the inside of the inverse sine function, we're dealing with a positive value here. So we ask ourselves, where is sine positive? And we understand from our all stations to central, sine is going to be positive in the first quadrant, and it's going to be positive in the second quadrant. So what this means is that we're going to be looking for solutions in quadrant 1, and we're going to be looking at solutions for this particular problem in quadrant 2. So then drawing in the equivalent triangles, our first solution is going to look like this, and our second solution is going to look like this. But the question is, how are we going to find these particular angles? And the way in which we do it is we use our theory from above. So we're looking at the relationship between the interior angle phi and the exterior angle theta, or the overall angle theta. And for the first quadrant, phi and theta, they're equal to one another. So what we can say is that x is going to equal the inverse sine of root 2 over 2. And then we bring up our calculator. So up comes the calculator, and we're going to type in inverse sine of root 2 divided by 2 and execute. And it's going to tell us the first solution for the first quadrant, and that's 45 degrees as we mentioned earlier. Now to be able to find the second solution, we have to look up again and we look at the relationship between phi and theta in the second quadrant here. And what we can see is explaining theta in terms of phi, theta is equal to 180 degrees minus phi. So to find this second solution, we're going to write, instead of theta, we write x, and we say x is equal to 180 degrees minus the 45 degrees. Because remember, this guy over here, because this is in the first quadrant, this is acting as our phi. Therefore, the second solution to this particular problem is going to be 135 degrees like so. And therefore, we can say that the solutions for x are going to be 45 degrees and 135 degrees, just like that. Bringing up the calculator to verify, we can go sine of 45 is indeed root 2 on 2, and sine of 135 is also the square root of 2 over 2. Now there's another way we can solve this in our calculators, but what I'll do is I'll show you a few more solutions, and then after a few more I'll show you how to get them, or get the calculator to solve these for you. So going back, we go to B over here. So for B, we're going to do the exact same method, but there's going to be one more twist in the story. So what I'm going to do is I'm going to rearrange the equation in terms of y. So in doing that, we take the inverse sine of both sides of the equation, and that's going to yield y is equal to the inverse sine of negative 1 over 2. Now, here's where things get different to the previous example. Over here, we're dealing with a negative result inside the inverse sine. So rather than asking where is sine positive, we go where is sine negative. Performing this, we write all stations to central. And we know that sine is positive in quadrant 1 and 2, so it's going to be negative in quadrants 3 and 4. So what that means is that we're looking for our potential solutions down here and down here. So drawing in the equivalent triangles, we've got 1, and then we've got number 2, like so. And what I'm going to do is I'm also going to draw in this triangle over here. It's not going to be a solution, but what it will provide is an understanding of what our interior angle is going to be, so phi. Now, carrying out the interior angle for phi, what we can say is that we go phi is going to be equal to the inverse sine of, and here's where I need to change something. Rather than going negative a half, I'm only going to go a half, and what this is going to yield is the interior angle, so the interior angle here of this particular triangle. And remembering that this particular triangle, it's almost exactly the same as this triangle here and this triangle here. The only difference is that these two other triangles in the third and fourth quadrant have undergone different transformations. But the quantities wise, they're exactly the same. So all the side lengths are the same and all of the angles are the same. Now, calculating the value of phi, I bring up my calculator and I say shift sine of 1 over 2. That's going to give me 30 degrees. Now that we've got the interior angle, we need to remember that we're looking for the solutions within the third and the fourth quadrant. So we're going to go up to our notes here, and for the third and the fourth quadrant, the relationship between theta in terms of phi is theta equals phi plus 180 degrees, and then theta equals 360 degrees, take phi. So I'm going to mark it on the triangle. So theta equals phi plus 180, and then subsequently theta equals 360 minus phi. So for our first solution, remembering that over here, this isn't a solution, this is just a step towards a solution. Our solution, the first one we're going to get is in the third quadrant, and it will be y equals, then we go 30 degrees plus 180 degrees. And therefore, the first solution is going to be 210. Then for the second solution, we're going to get 360 degrees minus phi, which will turn into 30 degrees there. And therefore, we're going to get 330 degrees, like so. And therefore, what we can say is that y is equal to 210 degrees and 330 degrees, like so. Now, I'm also just going to write some labels in here, third quad and fourth quad, just in terms of communication. So if someone else is reading this working out, they're able to see that the solution, so this 210 degrees is for the solution in the third quadrant, and the 330 degrees is for the solution in the fourth quadrant. Now, verifying these problems, I'm going to type in sine of 210. That will give us negative a half. And then I'm going to go sine of 330. And that will also give us negative a half. So what we can see is that we've got the solutions to this particular problem. Now that I've shown you this method, I'm going to show you a quicker way on the calculator to do it. So what we can do is we mash the exit button a few times here. I'm going to type option, then I'm going to go calc, so F4. From there, I can either go solve or solve n. Now in the past we've used solve, but now we're using solve n. Reason being is that we're looking for multiple solutions to a particular problem. Solve will only give you singular solution, solve n will give you multiple. So solve n And then I'm going to type in the equation here. So sine, and we don't have a y, but we can use the x instead. So sine x shift equals, then we're going to go negative 1 over 2. And then I'm going to put in a comma and tell the calculator to solve for x. Closing it all up and then hitting execute. So I'm going to give me a warning saying there may be more solutions. And here's where it looks a little bit weird, because it's going to give me a lot of solutions. So what I'm going to do is I'm going to scroll over, and what you'll be able to see is the two solutions that are in this list here are actually over here. The reason it's giving us multiple solutions is because we're not telling it the bounds in which it needs to operate in. So what happens is these two solutions here, they're for a single trip around the unit circle. These other solutions, they're for multiple trips around the unit circle. So 570, 690, 930. And similarly, you can also go backwards around the unit circle, but we're not going to do it in this particular course. So we'll just go to exit. Alright, moving down to the next examples. We have something increasing in difficulty. We've got tan z over root 3 equals 1. Now, solving this particular problem here, all we need to do is we need to do the same steps that we did before. So we're going to rearrange in terms of z. So doing that, I'm going to first multiply both sides by root 3. And this will give me root 3 on the right and then tan z on the left. After that, I'm going to take the inverse tangent of both sides. And we will get z equals inverse tan of root 3. And now, here's where I need to draw my unit circle, because we need to look where is tangent positive. Doing that, we write all stations to central, and we know that tangent's going to be positive in the first quadrant and the third quadrant. Now, the relationship between tangent, or the relationship between the interior angle and the value of theta for the first quadrant is going to be theta equals phi. And for the second quadrant, it's going to be, or third quadrant I should say, it's going to be theta equals 180 degrees plus phi, like so. Now, drawing in the equivalent triangles, we're going to look like this. And our next step is we want to calculate the values of theta, or actually I should say we want to calculate the value of phi, and then we want to calculate the values of theta based on that. So we're going to say the value of phi, in our case, is going to be the inverse tan of root 3. So I bring up the calculator and I just say the shift tan, then we're going to go shift square root 3, close it off. And it's 60 degrees. So that's our first quad. And then for the second solution, we're going to go z is equal to 180 degrees plus 60. And that's going to become 240 degrees, like so. And therefore, z is going to be 60 degrees and 240 degrees. Verifying that this is the correct solution, we're going to go option, calc, solve n, and I'm going to put in the equation. And lo and behold, the solutions that we calculate over here also happen to be the solutions that the calculator finds as well. So 60 degrees and 240 degrees. So what you can see is that it looks a little bit complicated in getting to the final result. And there's a few steps along the way, but there seems to be a coherent solution in which you can follow, or there seems to be a coherent method in which you can follow to get to the final solutions you can see down here. Now moving across to D. In D we have cosine of 2w divided by root 2 equals 1 over 2. So once again, what we're going to do is we're going to rearrange this in terms of, in our case, we're going to go to w. Notice we're going to w and not just simply w. It'll make sense when we get to the end. So to do this, we multiply both sides by the square root of 2. And that's going to yield cosine of 2w. Now I'm going to take the inverse cosine of both sides, and that will give us 2w is equal to the inverse cosine of root 2 over 2, our favourite exact value today. And now we're ready to go for the unit circle. So now we're going to ask ourselves, where is cosine positive? Because remember, inside the inverse cosine here, we've got a positive value. So I'm going to write all stations to central. And cosine is positive in the first quadrant, and it's positive in the fourth quadrant. The relationships for these guys are theta equals phi, and also theta is going to be 360 degrees, take phi, take the interior angle. From there, we're getting a solution here, and we're getting a solution here. So we're drawing the equivalent triangles, like so. And now we're going to calculate the interior angle, which will also happen to be the first solution to this particular problem. Now, to do that, we're going to go 2w is going to equal the inverse cosine of root 2 over 2. And then bringing up the calculator, it's going to be shift cosine. Then we're going to go shift root 2 over 2. And we already know this is going to be 45, but just showing the steps. 2w is going to be 45 degrees. Now, we could halve both sides and we'd get 22.5. However, we're going to hold off from doing this step just for now. What we're going to do is we're going to go for the fourth quadrant solution first. So we're going to go for the second solution. We're going to go 2w is going to be 360 degrees minus 45 degrees. And this is going to give us a value of 315 degrees, if I'm correct. So what this tells us is that 2w is equal to 45 degrees and 315 degrees. But remember, we don't really care about what 2w is, rather we care about what w is. So now what I'm going to do is I'm going to divide both sides of this equation by 2. And the interesting thing about this one is we probably haven't done this before, but left hand side we're just going to get a value of w, but on the right hand side we've got 45 degrees that gets divided by 2 and 315 that gets divided by 2. So 45 divided by 2 is 22.5 degrees, if I remember correctly. And then 315, that's going to be 157.5, like so. Now, verifying that we've got the correct solutions here, we can simply use our calculator. So solve cosine of, in our case, 2x for this calculator. Then we're going to get shift root 2, shift equals, then we're going to go 1 over 2. Tell the calculator to solve in terms of x, ignore the warning, go on up, and we're going to get 45 divided by 2 and 315 divided by 2. I don't like the fraction, so I can go SD. And we indeed find our solutions are in agreement. So 22.5 degrees and 157.5 degrees here. If I want to change from fraction to decimal, I can use this SD button here. So that will change to exact, to approximation, which is a good hint to know. Alright, final example, we're going to be working with E. So what we're dealing with here is cotangent of V is equal to 1 over root 3. Now remember, this is a reciprocal trig relationship, and that we know cotangent, so I won't do it in red, I'll do it in orange. We know that cotangent, so cot theta, is simply equal to the reciprocal of tangent, so 1 over tan theta. And we know that because of the final letter and the first letter here. So it's a reciprocal relationship. So what we're going to do is we're going to rearrange this particular equation in terms of v. Carrying out these steps, the first thing I'm going to do is I'm going to rewrite cotangent as just tangent. So it'll be tan v all over, or all under 1 I should say, and then we'll have root 3 over, or root 3 under 1. Now next step is I'm going to take the inverse. So I'll flip both sides upside down. This is going to yield tan v is equal to root 3. So it's starting to become a lot simpler here. Now the next step is I need to take the inverse tangent of both sides. Carrying this out, we get v is equal to the inverse tan of the square root of 3. And now we're ready to use our unit circle to identify where tangent is positive. So we know that all stations to central, and I should write where is tan positive. And we know it's going to be positive in quadrant 1 and quadrant 3. Carrying this out, I draw the equivalent triangles. So one in quadrant 1, one in quadrant 3, and here's where I'm going to find my two solutions. The relationships for these quadrants are theta is equal to the interior angle phi, and over here it's going to be theta is equal to 180 degrees plus phi. Finding the first solution to this problem, we're going to go tan, or v equals the inverse tan of the root 3. And that's going to come up as shift tan root 3. And that's 60 degrees. So now this would be the first solution for our first quadrant. For the second solution, we're going to go 180 degrees minus, or I should say plus, the 60 degrees. Adding these together, we're going to get a value of 240 degrees like so. And this will be our third quad. Therefore, what we find is the solutions for v that satisfy the equation above are going to be 60 degrees and 240 degrees. Now, when we're calculating this, we can't put cotangent into our calculators. So verifying this solution, we have to go down to this line over here, so the line underneath. Doing that, I'll mash the exit button again, and I'll go Option, Calc, Solve N. From there, I'm going to put in 1 over tan theta, or 1 over tan x, because we only have x on this calculator, and shift equals, then we go 1 over the square root of 3. I tell the calculator to solve in terms of the unknown, so x. Solving this problem, the calculator gives us all these solutions, all the infinite solutions to this problem, or at least the ones it can remember. And what we find is that these two solutions we found here and here also happen to be the two solutions that the calculator finds as well. So we can remain fairly confident that what we've been able to do is solve this particular problem here.